of 45 degrees. This one. Now this 45 degrees, 175 Newton, you resolve them into two components. The first component is the F sine theta. Second component, F cos theta. So after you resolve them into two components, you just ignore this. Just ignore this. Now, as I've said earlier, it has two implications. The first implication is on the normal reaction. So the normal reaction is now less, is mg minus f sine theta. At first, both of them equal, the normal reaction and the force, the weight is equal. But now with the help of f sine theta, your normal reaction is lightened. The burden is lightened, right? So I try to find what is the normal reaction first. Okay. Okay. Then another significant is the applied force. The applied force is F cos 45. This one. F cos 45, horizontal. So you try to calculate the applied force, right? F cos 45, 175 cos 45, and it is 123.7 newtons. So you know the applied force. How much is the frictional force? This one. Can you use this formula to calculate the frictional force? F equals to mu n.
Un is
Mu, you just leave it as mu first because the value of mu is not
the
even. So you try to calculate the frictional force mu n.
mu times
Yes.
n.
Normal reaction.
Yeah.
Mg minus F sine theta.
So that will be
This one.
yeah. So 50.
Can you use
Yeah.
your calculator to calculate the the weight minus the F sine theta? Use the weight to minus to find the normal reaction.
Okay. 366. 15 times 9.8 minus 175 times sine 45. So 366.
366.2 or point 3?
25.
0.25. Okay.
26. 366.26.
Okay.
No. Yeah, 26.
Okay. Then so you have found out the normal reaction. So what is the frictional force? You just add the mu in front. You add the mu in front. Oh, the next part will be to link up the net work done using this equation here. The net work done is F minus F.
Okay.
Okay. Okay. So the net force is F, the capital F minus the small f. And it is also the applied force, the component there, the F cos theta minus the frictional force. Then the net work done, you just add a d behind, just add the distance of 6 meters behind. Okay, so the net work done is given is 150. The applied force we have found out earlier here, F cos 45, and the mu coefficient of friction 366.26 you found out, substitute inside, multiply with the distance. So can you manipulate with the equation and find out the value of coefficient of friction, this one. Can you solve this equation? Find mu. You try, huh? You try. I go and get a cup of water.
So 7. Uh, 123.7 minus 106. Oh,
Okay, have you found out
0.27.
0.27, correct. How to get 0.27? So,
Yeah, I did that.
okay. So we move on to the next part. Okay. The next part is about kinetic energy. We're going to prove to you the formula for kinetic energy. Okay. Let me hide all this. How to prove the formula for kinetic energy. Okay, right. Let me explain to you the situation. The situation is like this. We have an object, right? And or before I explain to you this, we move back to this page. We say that over here, let's say take this simple example here, right? This simple example here. There is a force of 175 Newton acting towards the right, frictional force acting towards the left. Correct, acting towards the left. So there is a difference in force. There is difference in force, and this is the net force. This net force will produce what we call the net work done. Where does this net work done go to? Where does this net work done go to? That means when we do so much work, when we do work, this F multiply with the distance of 6 meters, we have done 150 joule of work. Part of it is absorbed as friction, and heat. It is dissipated as heat, sound, and so on. But the extra force produce the extra work. Where does this extra work go to? Not only, you see, if it fully goes to overcome the friction, then this will be 175, this is 175, they balance one another. All the work done is absorbed by the frictional force. But now it seems that our force is bigger than the frictional force. So there is that extra force there. And this extra force called the net force, it do some work called the net work done. Then the question is, this net work done, can we see the result? Where is this net work done? Where it goes to? So come